This episode of the ZuLoo Pōōdcast is sponsored by ZuLoo Inc., a benefit corporation dedicated to the goal of universal access to toilets, hygiene, clean water and sanitation through the power of social enterprise. Learn more at ZuLoo.com.
And actually, it's kind of interesting because the Spiro Tunnel, which you'll see some photos of, was used as one of a unique skier experience where it was the only, I think, skier subway ever that developed, where skiers would go deep into the tunnel and then be lifted out of a shaft.
How cool is that?
Side. I guess it was quite a miserable experience, but unique because they were soaking wet when they came out.
Welcome to the ZuLoo Pōōdcast, where we talk all things poop, toilets and sanitation. Through insightful news, impact stories and quirky humour, we aim to discuss and highlight the critical role toilets play in whisking poop out of our lives, the impact toilets have, or lack thereof, in the health and wellness of humanity, and what ZuLoo is doing to help solve the current global sanitation crisis.
Good morning, ZuLoo friends. We are here in Park City, Utah today, and we are so excited because we are going to be having a tour of this amazing facility. It's very unique in the world and specifically in the United States. We're here with Michelle De Haan. Good morning, and she's going to be explaining what goes on here exactly and how and why it's unique. And we also have another guest today, Shannon Mangum, who's with us. And she is the wife of the founder of ZuLoo. So we're so excited that she could join us today. So let's go ahead and get started. Michelle, do you want to go ahead and tell us a little bit about your background?
Absolutely. My name is Michelle De Haan, and I'm the Water Quality Treatment Manager here at Park City here in Utah. Mm-hmm. And this is a unique drinking water and stream discharge plant. It's called the Three Kings Water Treatment Plant. This is actually the city's largest investment in its history. Wow. And we're treating a unique source of water. The city has a rich history in mining, and so in the late 1800s, miners were seeking their fortunes with silver and zinc, and they ended up having problems trying to successfully seek their fortunes because of the fact that they were being flooded out with water from the mountainside, and it caused them to need to create drain tunnels to bring this water out of the mountainside so that they could be more productive. And that created the city's first drinking water sources, these mine tunnels. And so what we have done at this plant is design a plant that is removing 8 different metals that are naturally occurring because of the mining history. And we're doing so for stream discharge. We're actually discharging water from this plant into a local waterway that drains into the Great Salt Lake ultimately. So we have to remove these metals for regulatory purposes, and also because the water rate water customers are paying water rates, we're trying to drink as much of this water as we possibly can because it's being treated so well that we're actually removing these metals to non-detectable levels. The drinking water standards are actually less stringent than the stream standards. The stream with aquatic life and downstream uses for aquatic life have stricter standards than drinking water. So it's actually pretty fascinating when you think about the ecological world being more sensitive to metals than humans.
Okay. So. Thank you for that. That's really fascinating. So you said it was the most expensive build in Park City. Wow, because there's some really expensive real estate here. So can you give us a number?
Yeah, so and when I say that, most expensive as the city's commitment to the local community and our customers. So it was an $80 million treatment plant, and we're treating about 5,000 gallons a minute here, or equivalent to 7.2 million gallons a day. So it's a big resource for the community. We're providing environmental benefit, but also some resiliency and redundancy in our drinking water supply, because we're in a high desert environment, and this is actually the third of the treatment plants that I've had the pleasure of starting up since I've been with the city for 13 years, where we have a lot of different and unique drinking water supplies and sources of drinking water, all the way from wells that we can talk more about, all the way to a surface water source from a high mountain watershed, and then this mine tunnel water is also part of our supply.
Awesome. Okay.
So are you working with like some of these original mine tunnels?
Yes, these tunnels were actually developed for draining the water out of the hillside in the late 1800s. So the Spiro and the Judge tunnels are what we're treating here today. And actually, it's kind of interesting because the Spiro tunnel, which you'll see some photos of, was used as one of a unique skier experience where it was the only, I think, skier subway ever that developed, where skiers would go deep into the tunnel and then be lifted out of a shaft.
How cool is that?
Side. I guess it was quite a miserable experience, but unique because they were soaking wet when they came out.
Oh, wow.
And so it was usually a once-in-a-lifetime experience, but very unique.
So is there any gold in these tunnels?
Get to the meat. They're gold.
Yeah.
Metals. So the metals that we have at this plant that we're removing do actually include. It's interesting that the water doesn't leach gold or silver. But it does leach iron and manganese and lead and thallium and cadmium and zinc. And so there's 8 different metals that we're removing, and it's just interesting when you think about all these different things. But they were mining for gold, lead, silver, and zinc in the late 1800s that produced fortunes.
So mostly what they did find then was silver, and what was the other?
Zinc. Yep, those were the 2 predominant ones. And at the time, even lead became something that was very useful. And like making pipes, right? So there was a lot of use of lead back in that time that we don't use today because we've learned a lot about, the health and safety as it relates to those types of metals. But the real goal here is to remove metals for stream discharge and for drinking water purposes.
Yeah.
Yeah.
I have a real estate license, and that was the question that they went over a bazillion times in our training is the lead, like the lead paint, it was like lead. It's
Yep.
I'm like, who really goes and eats the lead? But off the paint.
Well, and it's been
anyway,
in our lifetime, there's even, leaded gasoline, right?
Okay.
So, think about all the exposures that we had as children that people aren't being exposed to today. And a huge focus in drinking water is to make sure that there's, no acceptable lead in drinking water. You think about the whole Flint, Michigan story and, what happened there with drinking water lead contamination that caused illnesses. So,
But that, because
well, it's kind of an interesting story because it's complicated scientifically, where they had a drinking water source that they were using, and they shifted to a new drinking water source that they thought was going to be a better quality. And when they had the previous plant online, they used a corrosion control inhibitor that coats the interior of the pipe walls. And so they knew they had lead service lines. So the line taking you from a main to a home is called the service line. And they were lead service lines that needed to have a coating on them. And so this corrosion control inhibitor, which is a chemical, was lining the interior of the pipe walls to ensure that lead didn't dissolve. And when they switched to the new water source, they stopped using that corrosion control inhibitor, and essentially it allowed that water quality to dissolve what was on the pipe walls and then start leaching lead from them. So a lot has been learned in the industry as it relates to lead releases, and a huge driver for EPA to get all lead service lines out of the ground all over the United States. And there's a lot of funding that's been put in place to ensure that happens.
so interesting. What year was that?
Ooh, I don't know the answer to that question, but it's probably been about 15 years ago. But it's been a big story in the industry for quite some time. Yeah.
Yeah, so why don't you tell us a little bit about your education and how you got to this level? And you also did some work in Arizona, right?
I did. So I started my career a little over 30 years ago in water and wastewater laboratories. I have a degree in chemistry.
Okay.
A lot of people in this business are engineers, so I came into it a little bit differently than a lot of professionals. I was actually pre-med in college and decided to go rock climbing instead of going to med school. So that's kind of
Love it.
the story. And so I used my chemistry degree to work in water and wastewater labs initially for a couple of years, where people would analyze for metals, just like we're, sending samples to a lab here locally. I did the analysis for those metals in the laboratory world for a couple of years early on. And then I started as the city of Scottsdale's in Arizona's first water quality sampler, and got very involved in EPA drinking water regulations and understanding, all the things that we need to do to make sure that we're meeting regulatory requirements and providing the best water quality to customers as we can. And I worked there for a decade and expanded, my horizons into the wastewater world and air quality and, the Superfund world, a lot of different regulatory programs, and then became a consultant and with a passion towards removing metals from drinking water.
And then you said, I want to retire in the most beautiful state with all the amazing mountains to climb.
Well, I'm not ready for the retirement part yet, but I came to Park City because of the unique challenges that they face from this mining history and the need for metals removal. There's some complex water quality here that is more interesting than a lot of places in the country.
And you're clearly one of the experts in the field, so
that's the case. Yeah, I'm super active in the American Water Works Association, and we talked about that just a minute ago. I wanted to encourage you guys to look up an organization called Water for People. That's an organization that does a lot of work on drinking water and sanitary waste as it relates to impoverished communities, and that's American Water Works is a great organization to help promote that for all different types of communities.
Awesome.
Okay, we're at the Spiral Mine Tunnel. And so, again, this was developed in the late 1800s when the miners were seeking their fortunes trying to extract silver from the earth's side. Mm-hmm. And they kept getting flooded out by water draining through the mountain. And so they developed these drain tunnels to basically get the water to move into them, and they became the city's first drinking water sources.
Incredible. So in the 1800s, they didn't really have the extraction equipment so did they just use shovels?
Well, they actually had very similar big and very large jacket systems where they would, today they use air, to help drilling, because one of the things we've done is in the last few years, we've spent a couple of million on shoring up the ceiling and the walls of these tunnels because they, over time become destabilized. Right. So we've had to restabilize the walls to ensure that the water continues to come out so we can treat it and use it. They're having built an expensive treatment plant.
So now we're actually inside of the mine. And like she mentioned, they've done a lot of work over the years to secure this. From leakage and just falling down people, right?
Yep. And it's, again, it was an interesting journey, and we could look at this outside, but where people would come in and use this to transport skiers when skiing came about. Mm-hmm. So that people would come inside of this tunnel and go back about 2 miles on a mine cart. Wow. And then they would be lifted out of the a shaft that takes you up to basically where today, if you've ever skied in Park City, there's a Thames chair, and that's where the skiers would come out of the skier subway.
2 miles back.
Yep.
And then they were how were they lifted up?
There was a hoist. Okay. That, they would take the skiers out on.
Some diehard skiers.
Yeah, that is some diehard skiers.
And they would get totally soaked.
Soaking wet.
Wow.
It had to be a miserable experience, but a memorable one. So one of the interesting things about this project is being in Park City. It's a relatively affluent community. This site was designed and built to fit naturally onto a golf course environment with some higher-end condos from an architectural standpoint. And, with our unique mining background, the architecture was really developed so that we captured different things as it related to the mining history in Park City. So in front of us, we actually have a flume that is raw water from the Spiro Tunnel that is being delivered into one of the golf course ponds. This is actually the water that we are treating here today. And there's actually even a spring on site. The box behind the flume is a spring we call Theriot Springs, and it's just very clean water draining from the hillside. And that water is also used at this plant, but doesn't have to be treated. It's blended with the tunnel water on the back end. We passed it a minute ago, but there are some signs along the way that we can look at with some of the history and what we're doing here to accomplish the metals removal that we're targeting. And there's a side rail little cart right there that has it is one of the old mining carts that they actually use to maintain the mine tunnels.
Yeah, I was saying to Shannon when I got here, I was like, is this the place? Because I was like, is this how? Because it looks so beautiful. I thought it was a resort or hotels. I'm checking my address. All right.
This is super fun because all the different sources are shown here.
Okay.
And so you've got the Spiro water source, the Judge water source, and then we'll talk through the treatment processes and what we're doing here at each stage of the metals removal. But we have, our rapid mix influent we'll go to in just a moment, settled water, our filtered water, and then finally we're removing certain metals and adsorbers at the back of the plant. And then we have disinfection in place with ultraviolet light and chlorine at the very end. And the tap that I have open right now is finished drinking water going to the taps.
Nice. Okay.
So, yeah. Yeah, you got it.
Kombucha. Yeah, it's great. I love how it's like wood and it's just
and the little wooden nickels.
Yeah, the wooden buffalo
with the buffalo on them. Yep.
So this is the water lab.
Yep. This is the water laboratory where our operators collect samples and they look at the history of operations over the last several days and to see if there's any changes in raw water quality from the tunnels that we're treating. These are unique sources that have a very neutral pH. These aren't like, we often think of mine drainage being more acidic. Like in Colorado, there's been places where you can see, a very low pH water. And this is actually a very neutral, if you think about the pH scale from 1 to 14. We're at about 7.5 coming in here. And there's other unique water quality parameters that we are just some of the metals concentrations that we're tracking as they're coming in to see if there's been any shifts in quality seasonally, or we've got miners in the tunnel maintaining them right now. And so they can actually disturb the water quality, and it will help us then as we're testing throughout the treatment process to see if we need to make any changes to the chemicals that we're applying here, because drinking water is very chemical intensive, and we shift the pH actually 3 times in this plant before it goes to customers versus wastewater treatment, which is actually much more biological in nature and counts on bugs to keep that treatment process healthy. Park City's council is very serious about achieving net zero goals with its buildings. And so this building was designed so that we are capturing a lot of energy. And to do so, we're actually taking advantage of the pressure coming into pipelines from higher elevations. Okay. And so the Judge Tunnel is about 3 miles up the road, and we are able to generate power using microhydro generation. And these units you'll see inside in a moment, but we're actually able to harness 186 kilowatts of electric energy to help us meet those net zero goals. Okay. And so we also have solar panels and then water-to-water HVAC systems that allow us to be extremely productive, where we're using tunnel water for heating and cooling in this building as well.
Okay.
The blue pipe right there is the microhydro that we talked about that's harnessing the energy that we're creating through, again, having pressure or head coming in from the raw water supplies. So each of these different pipes has the different raw waters that are coming in and being treated from the tunnels.
Rapid mix, okay.
We're adding chemicals for the first time into this process.
Okay.
So again, the board here is showing the treatment step, and what we're doing is in these little chemical lines, we're adding ferric sulfate, the coagulant I just talked about.
Okay.
The sodium hypochlorite is chlorine. So we actually make our own chlorine here rather than have it hauled in because it's more environmentally friendly.
Okay.
And we just and I'll show you this, but we have an area where we blow salt in, and then we electrify a brine solution, and that creates on-site hypochlorite, which is 0.8%, and household bleach is 5.25.
Okay.
So it's a much safer,
safe.
yep, to work with. We have a lot of water quality analyzers that help us make sure the process stays in the equilibrium that we expect it to, as far as, the pH of the water. This is where we're measuring to make sure we're getting up into the realm of 8.3. The chlorine residual is captured here at 0.7 milligrams per liter. Again, our goals, achieving our goals. And if they weren't hitting those levels, then we would change the chemical dosing.
Gotcha.
So.
No dogs allowed. That's good to know.
Yeah, Park City's a dog town, so it's one of those things. I mean, everybody's allowed to bring their dog to work, and the citizens who are coming to do treatment plant tours, and it's important that we're not adversely impacting the water quality and having somebody step on something they shouldn't, that a dog might leave behind and gets in the water. The oranger color is because of the fact that there's a lot of naturally occurring iron, and there's also an iron coagulant being added, the ferric sulfate that we mentioned. And ferric sulfate, because it has a lot of iron in it, attracts arsenic. And that's one of the things we're trying to do, is have these chemicals bind on to each other so that they can be filtered out downstream. So these cells are called flocculation basins, and there's huge mixers on the inside. And what we're trying to do is bring the water in and start to slowly mix it. And it's a little faster coming in. And then the mixers are actually 3 cells where it gets slower and slower so that the particles start to develop. So you can see at this point, you can actually see the flock or the particles have been developed to a point where they're big enough now to settle in these next basins. And it's important for our operators to visually be able to see that flock formation. So we put lights in these basins. And as you move downstream, what's happening is we're going to shift over to my left where we've got these sedimentation basins. And there's treatment processes as we move over to this side. And these plates are actually set up so that the angle of them allows for the solids to settle to the bottom. And then the clean water that's being processed falls into the troughs, and you can see how much clearer that water is. If you've ever heard of turbidity in water, that's the clarity of the water. We've significantly reduced it at this point. It comes in anywhere from 10 to 100 NTU, which is the unit for turbidity, and we're now down to less than 1. So
yeah, you can clearly see that. Yeah. It's awesome. So there's all the clear right there in the middle.
And another thing that's unique about this plant is that we're removing the solids so that we call it a zero liquid discharge plant. And that means we're not discharging any of the process into the sewer system. Everything's being reclaimed, and the solids that are being processed will ultimately be disposed of in a non-hazardous waste local landfill. So the solids that are automatically dropping to the floor based on the angle of the plates are then being processed in downstream locations, and I'll show you that final product as we.
Phenomenal. That's great.
I was wondering if this metal grid actually has some kind of property in it that attracts those particles and helps them drop to the bottom, or
the plates themselves, there's plates that run all the way to the floor, and the way it's set up or designed is that the angle of the plates are actually specifically designed so that a solid material will slide down it and promote that movement. It's not so much that the plates are attracting anything, but yeah, it's the angle of the plates. It's the physical properties. Okay, we talked about the solids that are being processed in the last building, and so they're being pumped over to these gravity thickeners that are behind us, and they're designed architecturally to look a lot like the tanks that are on the mountainside that were built, back in the mining days, where they actually had water storage also on the hillside for their own use. So it's, again, mimicking the architecture of the mining heritage behind us. And then there's a pond that's behind those that is actually where we are discharging treated water from here when we're not drinking it.
Was there a facility here before?
Yes. In the late 90s, the city built one of the first arsenic treatment plants in the entire country. So drinking water regulations, they constantly are looking at different standards and determining whether they're adequately protective. And what they did was assess the arsenic standard, which was 50 micrograms per liter. And then in the early 2000s, this EPA lowered that standard based on health impacts to 10 micrograms per liter. It's a big change, and that's why I got into this business, actually. When I was with the city of Scottsdale, we had over 30 wells that were impacted by the arsenic regulation. And so with that, the city's arsenic concentrations from the tunnels were 60 micrograms per liter, so above the old standard of 50. And so they built one of the first treatment plants in the entire country to remove arsenic, and were very involved in the research and trying to figure out how to do that. And the processes that we built then are similar to what we have today. Basically, we put a coagulant in the water, and we just filtered it then. We didn't have these upstream processes that settle solids and are more the workhorses today. We weren't able to remove things like zinc and cadmium then with that treatment plant. It predominantly removed arsenic and thallium, so those two metals.
And that was how many years ago? In the 1990s?
Yeah, it was built in the 90s and demolished in 2019 to make way for this plant. So behind me are large pressure filters, and inside of these filters are specialty media. It's called manganese dioxide, and it's very different than other surface water treatment plants throughout the country that use sand and anthracite to filter water. This media, because of its unique properties, has the ability to absorb certain metals like thallium and manganese. And this plant is really the first plant that's ever been designed for thallium removal with that unique scientific finding. The media also filters out any remaining metals that weren't removed upstream, and those include lead, arsenic, iron. We talked about manganese and thallium, and then any remaining zinc and cadmium come out in those filters. It's a black media that is basically removed as ore from the earth. And so it's a very unique material. It also is filtering out any potential pathogens. We often talk about open water sources like rivers having pathogens like cryptosporidium or giardia. And so this filtration does remove those type of contaminants if they were present in the water.
Incredible. I'm so glad there's really smart people like yourself that know how to take all this stuff out of the water.
Yeah, we had a lot of national experts support us in this project. We've got water quality consultants that, supplement my background that have helped us with some of these scientific discoveries. And we're publishing all over in national magazines, and I'm actually presenting at the American Waterworks Association Water Quality Technology Conference on the success of this project in November. So
it's coming out this November. And where is that located?
It will be in Schaumburg, Illinois, outside of Chicago.
Okay. So do countries around the world have similar facilities?
So throughout the United States, surface water is traditionally treated by conventional water treatment. And this is a version of conventional water treatment where you have the flocculation and sedimentation, filtration, and then both chemical and ultraviolet light disinfection. So it's pretty common technologies until we get to these specialized media like this and having to do major pH shifts. For example, the next process that's behind us is just another set of vessels, similar to what we have in the filtration area, and it's got a specialty media that is removing the last metal that's left, and that is antimony. Antimony is in dissolved form. It doesn't want to settle. It doesn't want to be filtered. So it actually absorbs onto a specialty material called titanium dioxide. It's white. It looks just like Tom's white toothpaste, which also has a lot of titanium in it. So, but yeah, that and to do that, so this media, unfortunately, has to be, it gets saturated, kind of like kitty litter, where you've got to change it out and replace it new. And we're going to have to do that probably every 2 years. And the cost of that is extremely expensive. There's only one supplier that has developed this technology, and it's going to cost us about $800,000 every 2 years to change it out. So to get the most life out of that media, we actually have to reduce the pH all the way down to 6.5 before we can go through those media. And we pilot tested at the old plant this entire process for a 9-month period to make sure that we understood the chemistry on how to remove all these metals through this final step of absorption process. And then downstream, the next location we'll go to is where we disinfect the water to go to the drinking water system. And then behind us, the other thing that you're going to see, or behind your shoulder, is a pink pipe. It's very common throughout the United States for pink pipes to be the color of reuse water. So a lot of, treated effluent wastewater plants that are reusing it for golf course irrigation, or in our case, snowmaking is another thing we use this water for. Vail actually owns a portion of the Spiro Tunnel supply, and reuse is promoted in a lot of places, and purple or pink pipe is also often the designation, and that's where we're discharging to the golf course ponds that eventually discharge over to a water of the U.S. McLeod Creek is our local watershed. We always push finished drinking water colors are blue.
Okay, so that's, and what is the green?
So that's actually the settled water from upstream processes before it's finished. So different colors denote different processes.
Gotcha.
So,
okay. Yeah, I remember that from the other plant that we toured, that the colors meant something. So,
Yep.
And the artist just brought that all back in. Yeah.
Interesting. I didn't know that manganese was a toxic metal, and here it is. I mean, I paint with that blue, manganese blue, cadmium light, yellow light, cadmium red. I'm like, okay, now I know why artists are always wearing gloves when they paint, So
I'll tell you another story about manganese. So, like, if you're down in St. George and you go to Snow Canyon State Park, or if you're at Zion and you see the redder rock and even blacker rock, that's manganese.
Okay.
when Darren, the founder of ZuLoo, when he was growing up, he lived in Mississippi, and we went back for his grandmother when she passed, and we're staying in her house, and he turns on the water, and the tub is filling up, and it's orange. And I'm like, I am not getting in that water, And Darren's like, I'm just going to stand in it and just, he's standing and doing a bath, like just rinse. And I'm like, no, your water should not be orange that you bathe in. I'm sorry. And
Unless you want a tan color.
and he lived there when he was a little boy, and he lived there. His teeth have orange rings in the back from the time that he lived in Mississippi, because the iron content is so high. I mean, scary, right?
Iron does generally look oranger, and manganese is more the brown or black colors.
Literally, that's
Yep.
he does like things that glow in the dark, so
What we're doing now is, remember those solids we talked about being over in the gravity thickeners?
Yes.
Well, they're a pretty unthickened solid at that point. And what's happening is that we're pumping water from the solids, from unthickened solids from those buildings over to here, and we're actually providing the finished portion of the solid waste, which has all the metals in it. And so what we're doing here is these are filter frame presses, and you can see this browner material is what's in my hand. And these are the finished product that is the metal that's all now solidified, and it's kind of like a brownie with powdered sugar on top, because it has all those metals that we talked about. The brown color of manganese is really picked up in there, and so we just pump that unthickened solids into these filter frame presses, and then we close it up so that it's nice and tight, and we blow in high volumes of air to dry it into cakes. And the white material is this diatomaceous earth that helps it slide off the plates and drops into a dump truck.
Okay, I was gonna say, so then it goes to the dump truck.
Yep.
And then it's taken to a location where it's...
Yep, the Summit County Landfill. It's a local county landfill, and we test it for TCLP, which is total characteristic toxic leaching potential. And that will tell us whether there's any hazardous compounds in the waste, and these are actually very low levels of metals that are well below those standards, so it can be disposed of just like your household waste. So this is our pickup truck that we are using for capturing the solids that were created in the filter frame press. The brownies with the powdered sugar on top that are loaded with metals, all the metals that we removed. All of our operators have to have their CDL licenses to drive this truck to the landfill.
So it just drops from up above, and then they take the truck and take it to the landfill. And how often do you do this?
About once a week. Yeah. The one we were just looking at from above, where, again, from the gravity thickeners that look like the water tanks, they pumped over here, and this is where we have unthickened solids blending inside of this tank so that it's homogeneous before it's pumped into the filter frame press.
Yeah, and so that way I'm assuming it wouldn't harden either.
Correct.
You're just keeping it moving, and then it goes into your filtration.
You got it.
Okay, Michelle, tell us where we're at now.
So we talked about this being a pretty chemical intensive process, and so we're actually in one of the three chemical rooms in this building, and this one is where we make chlorine. So we talked earlier about that we blow salt into the container behind us through the wall. Just traditional, it happens to be a company called Step Saver, is the local salt supplier for softeners all over town, and what we're doing is there's electrolytic cells behind us that are down here where water, soft water is added to the salt, and it creates a brine solution that is pumped into those electrolytic cells below us, and it's electrified. And the reaction then has two byproducts. One is hydrogen, which is blown out of the roof line and just dissipates immediately. And then the other is sodium hypochlorite, which is bleach. And this is a 0.8% solution of chlorine or bleach, where, as we discussed before, the household bleach is 5.25%, and most chlorine at water plants is delivered in liquid form at 12%. And so 0.8% is a lot safer solution for us. Interestingly, we actually provided water during COVID, or bleach like this during COVID from another treatment plant to disinfect the buses when we ran out of bleach.
Interesting.
So super safe to use. This is the disinfection building where all the water has been treated for metals removal, and we talked about pathogen reduction through the filters. Well, our final step of pathogen reduction is using ultraviolet light to remove any potential remaining Giardia or Cryptosporidium, and we apply chlorine for additional disinfection here. We raise the chlorine residual, which is required for treatment. And so this is where we get to taste the final product together.
Hey,
so cheers. Thank you guys for coming today.
Yeah, thank you.
So good.
I know, amazing. And it's even chill.
It's chill.
All right, so Michelle, can you just wrap things up for us?
Yeah, so it's super enjoyable chatting with you guys today and sharing Park City's water story. The Spiro Tunnel that we're standing in front of here is, the raw water source of the treatment that we just went over. And we're super proud to have been able to preserve the supply of the water from the tunnels, again, being the first drinking water sources in Park City, and being in a situation where we've been able to remove all the metals for human consumption, for drinking water, and for stream standards. And this, is a really great source of water for the community. And, just trying to provide the best quality drinking water we possibly can in this unique source. Kind of tells the story that you can do a lot to use different sources to provide high quality drinking water. They're unique treatment operations. So.
Perfect. Well, thank you so much. It's been so informative, and you're just so pleasant and intelligent, and just been great. So
Yeah, thank you so much.
You're very
Michelle.
welcome.
This
Really
has
enjoyed the day.
Really been a treat for me.
yeah,
So, you're welcome.
thanks so much.
Thank you for listening to the ZuLoo Pōōdcast. Follow us on social media at our links in the show notes below. To learn more, visit our website, ZuLoo.org. If you liked the podcast, be sure to subscribe, like, and comment. For even more ZuLoo fun, send us an email with your toilet stories to podcast@zuloo.com for a chance to be featured on the podcast. This episode of the ZuLoo Pōōdcast is sponsored by ZuLoo Inc., a benefit corporation dedicated to the goal of universal access to toilets, hygiene, clean water, and sanitation through the power of social enterprise. Learn more at zuloo.com.